So typically when you're dealing with these single step simplification of rational exponent expressions, you got to remember that these are designed to be single step. So the solution is generally a lot easier than you might realize. Remembering back to our exponent rules, when you've got an exponent, when you've got the same bases with different exponents, in a division problem, you subtract the exponents. In a multiplication problem, you add the exponents. And if you look carefully, that's exactly what this problem is. We're dealing with m as a base, but we have 3/4 minus negative 1/4 in the exponent of this one. Of course, 3/4 minus 1/4 is just the same as 3/4 plus 1/4, and 3/4 plus 1/4 is equal to just 1. So m to the 1 is what we've got here. So our solution is just simply m. So a very elegant little solution to that problem. Okay, so in this problem, the first thing we got to notice is that our exponents are the same. So there's a pattern that we need to identify, that we need to use. So based on that and the knowledge that if our exponents are the same and we've got a multiplication problem on our hands, we can actually almost reverse distribute that exponent to the outside of the parentheses and bring the rest of the problem inside the parentheses and work on that. So I put the 1 under the 96 because 96 is equal to 96 over 1. And then we just do our multiplication inside and get 96 over 3 with the exponent of negative 2/3. So we haven't even brought the root into this yet. Before we do so, I'd like to deal with simplifying this fraction and getting rid of that negative exponent, making it a positive one. So simplifying the fraction, we still have the negative exponent, and just to fix those 3's, they're supposed to be 5's. Okay, so to get rid of the negative exponent, we just flip the fraction, take the reciprocal, of course, and we now have a positive exponent of 2/5. Okay, so moving on from here, remember the rule where the denominator of the fraction becomes the order of the root. So we have the fifth root of 1 over 32 to the power of 2. So you can, of course, have that exponent 2 on the outside of the fraction. You can have it on the inside of the fraction, wherever you like to put it. Remembering that 1 over 32 to the power of 2 is the same as 1 over 32 times 1 over 32. If you had a numerator that wasn't 1, it would still take effect. So the fifth root of 1 over 32 squared is equal to the fifth root of 1 squared over the fifth root of 32 squared. And what I'm going to do in this case is I'm going to break it out a little bit, and hopefully you see some of the patterns in this, and we'll talk about the patterns a little bit later on in other problem sets. But if we break that out, 1, of course, it doesn't matter what kind of root of 1 you have, it's still just 1. 32 squared is 1024, and when we do a factor tree of 1024, one of the things that we're going to notice is that it is, of course, a power of 2. So 2 is what comes out of it. But just let's look at how that happens. We've got 2 times 512, 2 times 256, 2 times 128, 2 times 64, 2 times 32. Let me talk about 32 for a second, and if you actually take a look at what precedes getting the 2 times 32, you'll actually see 5 2's in there, and that is very interesting. So with the 5 2's, we can actually pull that out in and of itself and have 32 left inside and just have the fifth root of 32. It's very, very interesting. But when we break this whole thing up, we'll notice that we have 10 2's total, which is extremely interesting because we of course have the fifth root of 1024, so pulling 5 of those 2's out gives us, we'll start with 1 over 2 times the other 5 that we're going to pull out of this is going to give us another 2, and 2 times 2 of course is 4, so our answer is 1/4.